The set of real numbers x for which the series sum as n goes from 1 to infinity of, oh my, n factorial x to the 2n over n to the n times x plus x to the 2n converges is, oh my, I do not remember my series convergence test type things, or there's a formula for the radius of convergence of things like this. I wonder if it could just be the entire real line. Well, hold on a second. I mean, we've got x appears in the numerator and denominator. So I have n factorial divided by n to the power of n times x to the 2n divided by 1 plus x to the 2n. Yeah, I was thinking of, I wasn't paying attention to the fact that x is down here as well. So this is less than or equal to the sum as n goes from 1 to infinity of n factorial over n to the n x to the 2n, right? This is always positive. So by making this smaller, I make the whole thing bigger because it's in the denominator. And this, okay, now I'm not completely sure. Maybe I don't even want to do that, right? Because if I have very large values of x, then this is very close to 1. And if I have a value of x, say, between 0 and 1, this decays exponentially. If it's between 0 and 1, this gets smaller exponentially. Like this is, if I ignore that completely, this denominator, it grows a lot faster than this. And so, I mean, I would imagine that this sum converges if I ignore this term. I would imagine the sum converges. But and this is bounded by is this bounded by 1? Am I correct to say this? Why can't I erase this? Uh-oh. Seem to have frozen here a little bit. Okay, I think if I get rid of that, maybe up to a constant. Although I think this is actually just true. In which case I get something which doesn't depend on x, but and I think this probably converges, although I'm honestly not completely sure. I don't know why I can't erase anything. Oh. Yeah, I don't remember formulas for radius of convergence or anything like that. But I think the answer is going to be E, all real numbers. And that's just based off the fact that I think that probably converges. I don't have the most convincing reason for why that converges other than, and maybe it doesn't, maybe I really don't know what I'm talking about here, but yeah, I think that's going to be my answer, but not sure. There, and I don't for the typical formulas that deal with radius of convergence, I'm not even sure. I don't even remember what they look like. Maybe there's something you can do also with thinking of this expression over here as a Taylor series of something. But the coefficients don't really have a form that look like anything familiar or something that can be manipulated through derivatives or integrals to something that looks familiar. I mean, if this converges for any value of x, then I think it probably converges for all values of x. Any value of x other than 0, I mean. So yeah, that's my answer, but I'll let you know if that's wrong. Unfortunately, don't have a great way off the top of my head of figuring out what the answer might be. Thanks for watching.